Hey everyone, this video is a walkthrough for the Hot Wheels Discovery Lab and how to specifically make a data table and do the calculations for energy and finally calculate the speed of the car that it needs to go through a loop. We're going to be going through this in class, but in case you missed it or you need a refresher or further help, that's what this video is for. So if you missed it, check this out, or if you need some more help, glad you're here. So we're going to start with the data section. I'm going to zoom in a little bit. So in the data section, you should have a data table. If you not have a data table, you need to make one. So I provided a data table in some of the lessons, but I realized that some people had different data tables and they weren't making them correctly. So here's how to correctly do it. So what you need to do is you need to go to Insert, Table, and then when you see these squares down here, it's asking you to select the size of the table you want for the number of rows and columns. So for our lab, we're going to want 5 columns long and 6 columns down. That'll give us enough room to put in all 5 of the trials and the titles for each column. So when I do that, this is what I get. And then this is what the table should look like. So you're going to need to make a header for each column. And here's the basis to start with. I copy pasted it already. Oops, not that one. This one. Okay, so here's what you needed. You need the mass of the car in kilograms, you need the height of the track in meters, and you need the acceleration of gravity. Those are the basics. We're going to add to this table after we do our calculations. You also need trials. So trial 1, trial 2, and so on. I know some people did more than one trial, or more than 5 trials, which is great. So if you did that, if you go to the end tab here, you can either right click and hit insert row below, or if you hit tab, it'll automatically make a whole new row for you at the end, but that's only if you did more than 5 trials, which I know some people did. So from here, you should put the mass of your car in. So everybody had a different car, they all had different masses, but the really important thing is that it's in kilograms. I had some students put it in grams, and then our equation will not work. So your number should be 0.0 followed by whatever you got from the scale. If you use the kilogram scale in class, then it should be straight up the answer. But if you use the other gram scales and you have something like, let's say 77, okay, that's not right. That's not kilograms. 77 kilograms is very heavy. So if you have 2 whole numbers, it needs to be in this format, 0.0, then 77 should be how you do that. And that's going to be the same for each one. So I'm just going to copy and paste it in each trial box because the mass of the car didn't change as you went through the activity. Also, make sure you don't put any units in this box. It should just be numbers. The units are located at the top right here. Okay, so that's where your unit should be, not in the box. So if you have kilograms after that, make sure you delete it and just have the numbers. Otherwise, it's going to mess up our calculation step. Next, the height of the track. This is in meters. So you should have a number that is 0 point something, okay? Most of us measured with a meter stick, and that meter stick had centimeters on it, which is what you use to measure for the most part. I didn't really see many students go over a meter in the air, so I don't expect to see many numbers above 0, and that's fine. So if you, for example, if your track, if you started one of your trials and it was at 45 centimeters, okay, 45 meters is very high in the air. So again, if you just think through this, did I do this right? 45 meters is 45 meter sticks stacked on top of each other. That's not right. You did not have it that high in the air. So it should be 0.45, okay? So then whatever you had for your 5 trials, you should try it at 5 different heights. You should put that in as you got it. So I'm going to make up some random numbers here. So let's go with 0.67, 0.74, 0.87, and then 0.95. Okay, so those are some random numbers I made up, and yours should not match mine. So make sure you put in your numbers. Again, the purpose of this table is to simply show you how to make it. Some of you already have this, but that's how we do it. All right, the acceleration of gravity is in meters per second squared. But since we're on Earth, gravity affected every car when you drop it down the track at the same rate. So all of these boxes should be 9.8. Okay? So you just go ahead and put 9.8 in all the boxes, and that should stay the same. So the point of this lab was to see if you could, what the minimum speed was that was needed to complete one loop. So was that a success at this height here? So for your height here, was that a success? If it was a yes, if it did make it through the loop, you type in yes. If it was not a success, type in no. Okay? So, all right, so I'm just going to make this up. So I'm going to say no, no, say yes here for all these 3. So again, I just made that data up, but you should put in what you actually accomplished in the lab in there. So this is what your data table should look like when you're done, before you start the next step, which is the calculations. Okay, so part 2, calculations. For this calculation stuff, it'll be a lot easier if you do it this way. There's a reason why I'm not having you do it on paper, because it takes too long and it's tedious, and just this makes your life a lot easier, and it's a good skill to know because Google Sheets can do a lot of work for you, and we're going to be using it more in science class when we get there. Okay, so here's how we're going to navigate to the Google Sheet that I have started for you. It's going to be a basic template that you use to complete the calculations portion down here below. And you're going to paste your information down there. So here's what you do. Go to the assignment on Canvas. All right, so click on this. When you open this up, you'll see this. Follow this link and make a copy of the Google Sheet to complete the data section of the lab. Okay, so when you click on this, it's going to bring you to a page that gives you the option to make a copy. This is so that you create your own unique copy for your group and it doesn't intersect with anybody else. So click on make a copy. And this is what it should look like. Okay, so I'm going to zoom in here a little bit. Perfect. So here is what I need. Notice the colors here. That is the data from your lab. So in these orange boxes, you should be putting copy and paste the data that you collected. Okay. The required calculation of this here is the potential and kinetic energy. Okay. These should also actually be required calculations. Let me up that real fast. So in these blue boxes here are required calculations, meaning you have to do these. And I'm going to show you how, but this is data that's required for doing the rest of the lab. So here's what we do. You go back to your screen here. You copy all your, no, actually, copy. Let me double check what we're doing real quick. All right, so we copy the information that's in orange that matches in your box. So I'm going to copy just the information in the table. You don't need to overwrite the other stuff. So I go over here. I'm going to paste, Control V, and there's my information. Perfect. So again, to copy, you highlight the table, Control C to copy, bring it over, and in the first box of the table, Control V, and it automatically pastes your stuff. And this is exactly what I want. All right. So from here, we're going to start in this box, the PEKE box. So it should be column F, row 4. So in this box, we're going to calculate the potential energy for each trial, because the potential energy will give us the kinetic energy, because like we talked about, all energy in the system stays the same. It just transfers. So what you do is start an equation by typing the equals key. So in this box, hit equals first. You should see this little like upside down bracket pop up, and that means that you're starting a formula. So if you cover up PE in your triangle that I provided for you up here, you have M, G, and H across the bottom. So you know that you have to multiply M times G times H. But what Google Sheets can do for you is it can take those numbers and do it for you and repeat that process over and over again. So you don't have to type in M, you don't have to type in G, you don't have to type in H. So you click on the box that represents. So in our formula, M is mass. The mass of the car is in this box here, column B, row 4. So I'm going to click on that. The box should turn like a light orange color, and you should see this pop up here with a demonstration of what that box entails. So it's saying whatever number is in cell B4, I'm going to use that. So you don't have to worry about typing it in. The symbol for multiplication is the star or asterisk. So that would be Shift 8 on your keyboard is multiply. We want to multiply by the gravity, which is in this column here, D4. And then we want to multiply that by the height of the track we use. So hit star again, and then go click on height. So this is what your box should read, equals B4 in orange, star, D4 in purple, star, C4 in blue. So what that's telling you, and if you look, they're outlined in dotted lines over here, and that tells you what you need to do, what's going to happen. So when you hit enter, it's going to automatically calculate that for you. So sometimes it's nice, and it'll do a suggested autofill for you, and that's awesome. So then if this is what you want, which in our case it is, which is really nice, so thanks, Google, click check. And then what it did is if you click on each box going down, you can read double click on it, it'll read the code. It'll say, oh, I see you're doing a pattern. You're doing the first cell times the next cell times the next cell to the right. So it keeps going down these boxes, repeating the same function over and over again, which saves you all that time. Sometimes I've noticed that it doesn't work like that, and it might not give you the autofill option. If it doesn't, here's what you do. You come down here and you click on this blue circle that's in the bottom right corner of the cell. Your mouse should turn into a little plus. Click and hold and drag it all the way down until the last cell that you want here, and let go. It's the same process. So click on this little circle, drag all the way down until your plus is in the box that you want it to stop at, and then let go. Okay, so I'm going to clean this up, and I'm going to shrink the decimal places down to the hundredths place, which is what I prefer. If you don't do that, that's fine, but it just makes your data look neater. All right, next, we're going to do the velocity. This one's a little bit tricky because, like in class, this calculates v squared. V squared is not the same thing as v, which is why this box is in red and this box is in green. We do not want v squared as the final answer, but it helps our formula work easier if we have that calculated out for us. So if you cover up v in the triangle, you're going to see that it's ke divided by 0.5 times the mass of the car. Now, KE and PE are the same in this situation because we're holding the car at the top of the track and it hasn't started moving. But by holding the car at the top of the track, you've given the car energy, and all that potential energy is going to be transferred into kinetic energy at the bottom of the ramp. So when it hits the bottom of the ramp, the height is 0, like we talked about, so the potential energy equals 0, but that car is now moving, so the kinetic energy is at its maximum. So it's taken on all the energy that PE created. So start an equation by typing in the 0 key in this first box. So in G4, type equals. Okay, now the computer is looking for a formula. So we want to do the kinetic energy divided by the mass times 0.5. So what you're going to do is you're going to click on the kinetic energy box here. The divided by symbol is slash, so type in slash. And now it's going to look for mass times 0.5. So like we do in the Y's boxes when we handwrite this out, I tell you to put what's in the denominator in parentheses because it's important to do the parentheses first when you do this math. Otherwise, the computer is going to follow the instructions to the key. So it's going to follow the instructions too well, and it's going to give you the wrong answer. So parentheses, and then you're going to click on mass, which is all the way over here, boop, times Shift 8 or the star key, 0.5. So since 0.5 stays the same, you can just type it in, 0.5. And what that'll do is that'll keep everything 0.5 as we go down. So it's very important that you then hit close parentheses. So it should look like this, F4 slash parenthesis B4 times or star 0.5. So it's saying I'm going to take whatever's in this box, that's an orange, and I'm going to divide it by what's ever in the B4 box, which is the mass. And then I'm going to multiply that number by 0.5. When you hit enter, it'll give you your answer. And again, autofill, spot on, thank you. Click that. But again, if it didn't work, click on this. When you click on the first cell that has the code in it, you're going to click and drag all the way down, and that'll do the same thing. Now, last step. We've realized that this is v squared, so this is not the actual velocity that your car went at the bottom of the track. You need to take the square root of that. Okay, so again, that's not a math thing that's easy to do. So again, making a computer do it for you is super awesome. Saves your time. So in the velocity, the green velocity, underneath the green velocity box, because again, this is what I'm going to be looking at to see if you calculated it correctly. Do not stop at v squared. So I'm going to hit equals. Okay, so I want the square root of whatever number is in the column next to it, in the column G. So the square root in Google Sheets is a special function, so you have to start typing it out, and it'll give you a list of programs that it knows how to do. So I'm going to start typing square root. So SQ, and I only got 2 letters in, and there it is. SQRT is the abbreviation or the computer program that Google Sheets knows in order to calculate what you're doing. So it says the positive square root, or the square root of a positive number, and that's what we want. So click on that, and you'll see how it automatically popped up and formatted, and you should see this green box come up, which means you're doing it right. So it's asking you, all right, so what value do you want me to take the square root of? Fortunately, we calculated that already, so we're going to click on this box here. So it should say SQRT in caps, open parentheses, click on G4, which is the first box you want. Close the parentheses, and that's it. You're done. All right, so now it calculated that for you, and then just double check to make sure the autofill worked. Again, if the autofill did not work, click on the first box you did with the calculation correct and drag it all the way down to the box you want to stop at. Let me clean up this data real quick so that it looks a little nicer. So I'm going to click the decrease decimal point over here, all right, and change it until it gets to 2 points past the decimal. So this is what you want. This is what we're looking for, this column here. So at the height of 0.45, it went 2.97 meters per second. I added this over here just for fun, to show you how fast miles per hour that is, to kind of give you a reference, because I know meters per second is kind of a new concept. And this is it. So that's it. So I also included a self-populating data chart down here. So if you look, oops, sorry, down here, zoom out one more time. We have that. So it will help you get an idea of what we're calculating. So this says the speed, velocity of the car, and it has the height of the track. So you can see that as the height of the track increases, the velocity of the car also increases. So the first success of our car was at 0.74. So that means that the minimum speed that it needed to go at was 3.8 meters per second. That's kind of what we're drawing from this. So in order to get this back into what you will send to me, copy the whole table, Control C, go back to your assignment here. In the top first box, hit Control V, and wha-bam, there it is. This is what you need. I would also like to encourage you to include the calculations and excuse me, and the data table chart that I made here. So click this, Control C, go back, Control V, and you can paste linked. Gives you the velocity track right there. And then I'm going to go over CER with you in class. So that's how you do it. This is what I should expect to see when you were done with the data section.